Okay, so here are two trig limits, right? All we need are these two trig limits, and we can, these special limits, and we can simplify lots of more complex trig limits, right? So let's start with this one. What if we want to do, I want you to find out what's the limit of sine 4x over x as x approaches 0. Think about that one a little bit. Okay, ideas. I'm going to change one little thing here about these guys. I think it's a little better to write them in terms of theta because it reminds you, usually we're talking about x as our independent variable, and it reminds you that theta can be different. So this one is sort of trying to match this one, isn't it? But it's not, because this theta is not the same as that one, is it? They have to be the same. So what do you think I could do here? Multiply bottom times 4. Okay, but I can't just multiply the bottom, right? And the top. Good, there we go. Okay, so if I multiply both the top and bottom by 4, that looks better, doesn't it? Right? Now I could write this as the limit of 4 times the sine of 4x over 4x as x approaches 0. Two problems. Not big problems. We can resolve them easily, but what are my two problems? What are the two things that don't work? Go ahead. How does this look different from our standard form? There's a 4 in it, right here, right? Okay, but that's a simple property of limits. What do we do if I have the limit of k times f of x as x approaches a? What can I do with the k? I could separate it, right? I could break it into two limits, really. I could make it the limit of k times the limit of f of x, and the limit of a constant is just itself, right? So in other words, in the algebra step that we're gonna take away from this is we can always extract the constant, meaning we can pull it out in front of the limit. Okay? So there's one thing we can do. We could write this as, pull that out front, so we get 4 times the limit of sine 4x over 4x as x approaches 0. There's one other thing, though, that's not quite matching. Everybody see it? See if this checks off. I've got, go ahead, you got it? We got the limit of sine theta, check, over theta, check. Oh, that's different. We need as theta goes to 0, but our theta is a 4x. What do you think? Could I put a 4 there? As x goes to 0, would 4x go to 0? It would, wouldn't it? Right? Yeah. That makes sense? It's going to go at a slightly different rate, but it's still going to 0. Everybody agrees? 4 times 0 is 0. So I can just add a 4 there freely. That's okay to do. Right? And now it matches. Now all this stuff in here fits our standard form. So what's the value of that limit? Yeah, this whole thing is just going to go to 1, and so I get 4 times 1 equals 4, right? Make sense? Okay. What if I had, let's try something like that. What if I had, about that one? A lot easier. What could I do with that one? One step.
Make it 1/4 times.
Very good. Right, I could just pull out the 1/4, couldn't I? I could just make this 1/4 times the limit sine x over x as x goes to 0. That whole thing is 1. So I get 1/4. Okay. All right. Another one. Oh, this is a tough one. Ooh. This is kind of bad. Does that look anything like either one of the limits? Well, what's the big difference, obviously, right from the beginning? Yeah, pi over 4. So this doesn't match either of them, right? This is one, and yet tangent of pi fourths is what? Think unit circle, right? Pi fourths is right there, isn't it? The coordinates are the same. Square root of 2 over, right, so each of these is going to be square root of 2 over 2, each coordinate. But the tangent is the ratio of y over x, right? So it's 1, right? It's sine over cosine, isn't it? This is the sine, and this is cosine, right? And so I'm going to get 1 minus 1 over square root of 2 over 2 minus square root of 2. I get 0 over 0, don't I? Right? Yikes. So what can I do with this one? This is good trig review. This is just a lot of trig. Because now we can't, this is one where, you see, we're not going to be able to just have one of our special limits pop out. We've just got to factor this in a way where we can cancel something important. Yes, sir? Okay. Okay, good. If we split tangent into sine and cosine. Right? Something like that. And then top, we could do something with the top, couldn't we? Right? Right. Okay, good. So we get a common denominator. Is that what you're saying? Because we could make this cosine over cosine. Right? See what I'm saying? And so then that's going to become cosine x minus sine x over cosine x. Everybody okay with that for the top? If I get a common denominator. Right, and then on the bottom, we still got, right? Right. Close. You don't quite. Everybody agree with that? And remember what our goal is here. When I've got I'm simplifying a complex fraction, meaning fractions of fractions, I break the top into one big fraction, bottom into one big fraction, and flip and multiply, right? So then what am I going to get? So I'm going to get the top cosine x minus sine x over cosine x times the reciprocal of the bottom. Okay, we're multiplying so we can almost cross cancel, right? What do I need to do to be able to cross cancel? Okay, I could factor a -1 out of this guy, for example, right? If I factor out, remember that's just undistributed. If I undistribute a -1 from this, what is this top expression going to look like? Negative. Good. So negative cosine plus sine. Isn't that just sine minus cosine? Everybody agree? So we'll replace that with that guy, right? Make sense? And now look what happens. Now I can cross cancel. I'm going to get this guy cancels with this guy, just leaving me a -1 on top. Make sense? Okay. And things are looking a lot better. Now I've got the limit of, on the top I've got -1 times 1. On the bottom I've just got cosine x as x approaches pi/4, and so I got it, right? And I can now evaluate this limit directly. I just get -1 over square root of 2 over 2, right? Yeah. So then that's going to mean the reciprocal of square root of 2 over 2 would be 2 over the square root of 2, which is what? What's 2 divided by its square root? 2. The square root of 2, right? Oops. Make sense? Okay, so that's, I mean, not that tough, but it's, the idea is you want to, you know, these kinds of things, you've just got to simplify the trig. Some of the things that we do may not work in real life. I mean, but you know that if you have a tangent, you always want to rewrite that in terms of sines and cosines, right? Simplify this as much as you can, and then just see if you can coax out some cancellation, right? Okay. All right, I think you guys just need to work on this stuff a little bit. Okay, I'm going to see if I can steal Chromebooks for the rest of the period. If not, I've got a lab.